Good afternoon. Welcome to GetFPV and welcome to our new GetFPV studios. I'm excited to be here with you today. My name is Andy Graber. I'm the general manager here at GetFPV, and we're really excited to get to share with you today a brand new product that's been in development for a long time, named the Lumenier Duality Dual-MOX Antenna. This antenna is really cool, really unique, and I'm going to share that with you today. And we have the special guests as well with us, Hugo from TrueRC, the developer of this antenna. We're going to bring him in. We're going to talk a little bit about it, show you guys some of the behind the scenes of how this antenna was made, why it was made, some of the features of what make this antenna so great, and maybe something that would be useful for you and your drone, and specifically the DJI goggles and the DJI FPV drone of what it was designed for. So feel free throughout the stream, if you're live with us today, ask questions. We'll do our best to answer them along with you. And Hugo, it's a great chance for you to ask a question for the designer of this antenna. And without further ado, let me bring Hugo in here to talk with us, and we'll get started.
Hi, Andy.
Hey, Hugo. Thanks for joining us. Excited to have you here. What are we showing people today? Why don't you give us a little quick background of what it is, and I'll show people on camera.
Well, it's a new dual band antenna for aim at the new DJI FPV drone. So it needs to be dual band. So I designed a dual band MOXon for this. The new FPV drone being a linear MOXon are especially well suited to give the best range to this drone. So I made a special MOXon which works on both 2.4 and 5.8 bands for use with this drone and the DJI FPV goggle.
Awesome. Well, let me show people what it looks like so we can start talking about some of the features here and what makes it so great. Here, I'll turn on the camera. We have an overhead camera here. Here, let me get it in a shot. There it is.
As you can see, it's pretty much the same size as a regular 2.4 gigahertz MOXon.
Yeah, I mean, the first thing I thought when I saw it, I saw drawings of it early on, but when I saw it in person, I was like, wow, this thing's actually really small. Like, it's smaller than I thought. So, I mean, you can see it's, not much bigger than my finger in terms of the antenna size. For an antenna that's dual band, works on 2.4 gigahertz and 5.8, I find that pretty amazing. I think of antennas for 2.4 usually bigger than this. So, I mean, how does it work that it can be so compact and work on dual channel like this?
Well, it's hard to explain in layman's term, but we started with a regular MOXon. It started with our true MOXon that we make at TrueRC. We make a version for 900 megahertz. We've been making for a while, and recently we made the 2.4. And then by tinkering, I was able to add a few elements and have a point of resonance at 5.8 as well. Just a bit like we did with the Omni, the Duality that Lumenier recently released last year, I guess. Yeah, and after that, I used the same layout as the 2.4 MOXon, and with the use of a high frequency PCB laminate that keeps the antenna efficient.
Yeah, it sounds awesome. I don't understand all of it either, but it sounds really great. I know it works well, and I think that's what most people will find out when they use it. They'll be impressed with how well it works. I mean, the specs on it, if you look at the website, it's live right now for everyone if you go on the site as well, and I can show you where that is. Here, let me turn that screen on real quick. So we have it live on the website right now. We have a couple versions of it. So we have a set of 4. You can buy all 4 at once. You get a little bit of a discount, and you can put those on your goggles. They're designed to go on the DJI goggle if you want maximum range. This is for the dual band if you're using the DJI FPV drone. And it can go much further because of the higher gain, and it's a directional antenna. And this is a linear antenna, which matches the stock DJI drone as well, which uses linear antennas. Which I think in the FPV world, we're so used to using circular polarized and feeling like that's the best. But I mean, Hugo, maybe you can tell us why a linear antenna in this case can actually work very well and what makes that a good choice for this type of antenna.
Well, the advantage here is because they have many antenna. They have 4 antenna on the goggle, and they have 4 on the drone itself, and 2 of which are vertical, and the other 2 are horizontal. So there's always at least 2 antenna that matches polarization. So
Yeah,
that's
that
why you
makes
can get
sense.
away, yeah,
And
with
I've seen too, like with the
polarization.
digital signal, just the way that it can, pick up the packets versus an analog, where if you have interference, you end up seeing like the snow or the graininess. Where I think digital it handles it differently. It seems to do much better with multipathing and other situations where linear might suffer in an analog situation. In a digital setup, you actually have some benefits from that potentially. Is that right?
Yes, yes. You can gather data from a bouncing signal. You can potentially resend data that haven't been able to be transmitted correctly. So yeah, the digital have an advantage, and they can benefit from some not interference, but from reflection in the environment.
So before I go over some of
Yeah.
these graphs here, maybe let's look at the specs real quick.
Hmm.
Some of the features just to call those out. So we're talking about 2 different frequencies.
Yeah.
The bandwidth on 2.4 is about 100 megahertz, so 2.4 to 2.5.
Yeah.
And then on 5.8, it's what, about 300 megahertz, so 5.6 to 925, which covers the entire 5.8 band that we're used to flying with. So that's pretty awesome. It
Yes.
covers the entire band of everything in 2.4 that you would use and everything in
Yeah,
5.8 type of
you
band.
could use this antenna on 5.8 analog if you want to use a linear antenna. It will works. It will works fine. Yeah. Or you
Yeah, I
could
think
use it on a TBS tracer long range system as well.
okay.
It would be
Yeah,
perfect.
yeah, I have one here. I can show people just to show you how it works. This is a TBS tracer, microtracer module, which is also RPSMA connector. So you could screw that right on and fly as an upgraded antenna over the stock one in terms of a long range directional antenna, which I
Yeah.
think that's really cool because I mean, if you know where you're going to fly and you just point your radio kind of at that to some degree, then this is going to get you longer range compared to a stock dipole. Is that right?
Yes. And don't believe that the antenna is not as good as a dedicated 2.4.
Yeah, I thought that was interesting when you told me that earlier.
Yeah.
So this is a dual band antenna, which you would assume by doing both, you're probably sacrificing in something. But Hugo's saying on the 2.4 frequency, it actually is 100% or 99% efficient. So you're not
Yeah.
really giving up anything by
No.
doing that. You're really just gaining the versatility of one antenna that can do multiple roles, which is really cool. So you could have this antenna, use it for your DJI goggles or some setup that you want, either on 5.8 or 2.4, or you could use it on a transmitter that's transmitting on 2.4 like this, or if for some reason there's a transmitter at 5.8 in the future that you'd want to use it on, that would work for that too. So it's like one antenna that does just about all the frequencies that we care about in FPV, mainly being 5.8 and 2.4. I would say that many of us fly on. And some of the newer transmitters are switching over to 2.4 even for long range.
Yeah.
So I think that's really interesting. The gain on this is rated at 5.9 dB, which is great, especially for how wide the field of view is on this. So you
Yeah.
get a lot. I've seen a lot of directional high gain antennas, but then you're sacrificing beam width. So it's great, but you have to be like pointing right where you're flying, which doesn't always happen. We know in the real world case, you move or you shift with your controller, your goggles, and all of a sudden you fall out of where the video range is. But with this one, it's like 120 degrees of horizontal beam width. So that means almost everything in front of you, you're good to go as long as you're pointing kind of towards the direction of where you're flying. And even with this, it has some bubble of coverage behind you, so it does cover a little bit of range behind you, depending on how you're set up. So a gain of 5.9, how does that compare to a stock DJI antenna that you might get with the goggle by default, which is kind of that dipole or the F style, I think, dual band antenna that comes with the stock V2 goggles? How does this compare with that in terms of dB gain?
The stock antenna are monopole, 2.4, 5.8 monopole, and they are about negative 3 dB of gain because they have low efficiencies because of they are monopole. So basically, they are half antenna. The Moxon being a full wave antenna got its full efficiency. and so they have close to 6 dB. So it's 9 dB above the stock one. So at 9 dB, you have twice the range and then some.
Wow. Okay. So that translates. Yeah. I was asking you the other day about the dB and how that translates into like layman's terms of how much you get asked all the time. How much more range am I going to get out of this? Which of course depends a lot on the situation of the RF environment. But
Yeah.
the general rule, you're saying 6 more dB would be 2 times the range usually.
Yeah.
Is that right?
Yes. Yes.
Right. So you're talking, you said 8 or 9 additional dB over stock antenna. So that's well over 2 times the range you would expect in terms of the gain that you get with an antenna like this. So popping 4 of these on your goggles, you'd expect that you would have much improved range compared to the stock antennas. Is that right?
Yes.
Great. So what if you want to mix and match? Because maybe you don't want to have all 4 on your goggle, or maybe you still want to kind of fly around you, so you need some signal behind you. I'm sure some people may think of that. So like, what could you do? What's some suggestions on how you could mix these? What if you only had 2 of them? How would you do that?
I will put the 2 marks on the bottom left and top right.
Okay.
And then
So
the other 2 will be omnidirectional.
Okay. So we could put like the Lumenier Duality,
yeah,
the circular polarized antennas on the other 2, and then you have these 2 as higher gain directional antennas. So that would kind of mix the best of both, where you still have some omnidirectional coverage, circular polarized antenna, and then you'd have these as directional linear antennas for where they're pointing at. Is that right?
Yes.
Awesome. And then for how you should point these, can you explain a little bit how the radiation pattern comes? Let me bring back up the website, and we'll kind of show people these graphs and how the radiation pattern works. Meaning, for those of you who don't know the radiation pattern, that's like the effective coverage of where either the transmission or the reception, where the antenna is listening to receive signals. So in this case, you can kind of see just a sliver of the antenna in the middle here. So it's horizontal to us, I would say. So it looks like
it's a top view.
Yeah, the top view. So most of the signal is out in front, straight shot of the antenna. So you have the highest gain right in front of it, and then you have a small bubble below. And this is on the 5.8 gigahertz. If we go over to the 2.4 gigahertz, now this is when it's a side view. So it actually looks very similar between side and top. It does change shape slightly, but on both of them, the strongest signal's out in front, right?
Yes.
So if you're flying, I guess you kind of want to have this antenna vertical and then pointing where you want, or I guess horizontal could work too. It just changes the shape slightly. Would you have one preference over the other?
I would have a preference vertical, because the 2 front antenna on the drone seems to carry the more bandwidth, the more video bandwidth, and they are vertical.
Okay.
So to match them better, yeah.
Mm-hmm.
Or you could read them somewhat, because so the drone always change attitude somewhat.
Sure. While it's flying, it will be tilting. But ideally, you have a linear antenna, both vertical or both horizontal at the same time, because you get the most crossover of the reception and transmission. Yeah, that makes sense.
The drone having 4 antenna, then it can select the one that matches the best.
Awesome. You guys, those who are just joining us to stream right now, we're talking about the new Lumenier Duality Dual-MOX Antenna that just got released today. These are antennas designed specifically for the DJI HD V2 goggles and the DJI FPV drone that works on dual band. The unique part about these antennas, though, being dual band, is meaning they don't only work on one frequency. So even though they're designed for the DJI goggle and the FPV drone that does take advantage of dual band currently of both 2.4 and 5.8 gigahertz, as we talked about earlier, these work well on 5.8 and they work really well on 2.4, even if you're only flying one frequency for that use case. So they're very versatile antenna. The other thing I think is great too is they're relatively low cost. Some of these more advanced antennas, the manufacturing process has to raise the cost because of how they're put together and the materials. But these ones, being a more simpler design in terms of the manufacturing, they're pretty low. So you get a set of 4 for $55 or a single antenna for $15 right now. So these are on sale at GetFPV.com, the Dual-MOX antenna, and we're shipping them today. So you put an order in today, they'll ship out either today or tomorrow. And if you're outside the US and you want your dealer to carry it, these are available for wholesale too. So talk to your favorite dealer, let them know you want to have the access to these antennas, and we'll ship them out to those dealers too if they place an order. So this antenna is the first of a few antennas we've been working on, and I'm excited that we get to share that today. We have some more antennas, you guys, coming out in the future. I can't talk about them really much more, but we'll tease you that there's more coming soon. This is the new dual band, dual MOX antenna, taking the MOXen design, make it into a dual band antenna with some of Hugo's magic, and then the production of Lumenier at their factory there, and putting this together in an awesome package for us that we can just pick up, buy, and fly. One feature in the production here that I just call out, there is a molded piece of plastic on both sides. This snaps together and provides a really nice locking fit around the PCB element. So most of the time antennas like this, you'll find it's just a wire that is soldered to the PCB element here, which works well, holds well, but it's a little bit fragile if you were to bump it or nick it by accident. You set your goggles down and hit it. So we reinforce that with this plastic mold that goes around it. It locks in place and it really takes all the stress off of that solder joint. So it's a very durable antenna, even though you're usually not going to be flying with this antenna. It'll be on your goggles. But if you happen to bang it around, it should hold up pretty well. And the PCB itself is actually relatively thick and durable. So it's not like a flimsy little piece of paper. It's got some shape to it, and it's a hard antenna. The cable itself too is flexible. So it's like a semi-rigid cable, meaning you can flex it up to 90 degrees in any direction. That is very helpful depending on your use. For the goggles, you can bend that in terms of where you want to fly. If for some reason you want to fly, above you, you could point these things up higher and point the one below it up higher too, and get that signal pointed in the direction you're flying. You can point them out sideways, forward, so 90 degrees of freedom of how you want to bend them in any direction that you choose. And that makes it a really nice option versus just being fixed in one position. Same thing with if you're using it as like a transmitter antenna, like on this system. So say it's on your radio. Different people hold radios different ways. I hold it kind of like this. Some people hold it like this. Some people hold it down. You'd want to be able to bend the antenna a little bit in the direction that you're flying or holding the radio, so you're not pointing straight at the ground. So if your module's here pointing this way, now I'm actually pointing straight out instead of pointing straight up in the air, right? Which wouldn't be ideal in terms of your antenna placement. Same way if you're flying with your hands down a little bit, you could point it up and get a better field of view of pointing your antenna where you're flying. So that's a small feature just with this semi-rigid cable that allows it to point where you want, 90 degrees. We have a couple people in the chat I've been seeing chiming in. Thanks for everyone joining us. Josh Campbell says hi. Yako likes the new background. Thank you. We'll have to do some behind the scenes kind of all the drones you see on the wall. There's a lot of history on the wall here, which I'm excited to share with you. And at some point we'll go over some of that. Brian says, I love my MOX antenna on my tracer module. Sounds like he's already using a MOX, and that works pretty well for him. So this one would work well too if you don't already have one. Nice. Thank you for everyone joining us. Wood FPV says, what's up? Any idea when Nebula Pro will be in stock? Wood, I think we have actually a shipment coming very soon. They said they have the chips finally came back for another production batch. So we should be getting some more Nebulas in hopefully by the end of this month. I'll have to look at tracking to see where they are exactly. What else, Hugo? Anything else you want to talk about related to this antenna?
Well, I know some people modify their DJI radio to put external antenna, and those will be perfect for that. So if people want to, tweak their radio using, installing external connector, then this dual band MOXen would be just perfect.
It's a good point. Yeah, on the stock radio that comes with the DJI FPV drone, of course, your control signal is over the same frequency as the drone from your controller. Now that controller, it's not made to where you can just screw on a new antenna, so you would have to modify it. But like we're in a hobby where many people do modify what they have to get better performance. The stock antenna that comes on that controller, can you describe what that is and how that's different from what this MOX would be?
The stock antenna inside the controller is similar to the one on the drone. It's a PCB dipole with with dual band, so it's very similar. so it's a low gain omnidirectional antenna, and replacing it by a directional antenna will significantly boost the range of the controller. Yeah, being the drone having less range, I think that does the video side does have less range, but with more range on the controller, you could have more penetration and fly in more difficult environment. Yeah.
So on the controller, how many antennas would you need? Is it one or two?
You will need two. There's two antenna. Yeah.
Okay, so if you want to go for a full upgrade, I guess you could do 4 on the goggles and then 2 and modify your controller too if you're using the DJI controller.
Yeah. Or the V1, the black controller that people use with the DJI FPV. Then this one is easier to modify. So this
And
could
that
be
one's fixed to 2.4, I think. Is that right? The original controller you're talking about?
Yeah, it's fixed to 5.8. Yeah.
Or is it 5.8? Okay. Interesting. Yeah, that's a good point about those people who want to potentially modify the controller if they want to get a little extra directional range. This could be a good option for that too. You would use, I suppose, an adapter from the PCB board of is it like a UFL? It would go to an RPSMA?
Yeah, it's UFL to RPSMA, yeah.
Okay, and then you could mount this to the RPSMA connector. Okay, that makes sense. Awesome. Hey, thank you. Odd said he grabbed a set of 4. He says, thanks, Hugo. Appreciate it, man. That's awesome. Hope you enjoy them. We'll get them shipped out to you soon. You might be the first one in the world to get them other than ourselves here. William Perry says, is there any modulation graph for optimal direction? I guess he's probably talking about the radiation graph we just talked about.
Yeah, we could show them again.
Yeah, let me show you here again just to go over it one more time quickly. This is one of the radiation patterns here, William. So yes, the best way in optimal direction is in front of the antenna. So if you're holding it like vertical or horizontal, it would be straight in front of it. So pretty much point the antenna to where you want to fly. You're going to have the best coverage and range that way. And the maximum gain there is up to 5.9 dB out in front of you. And for those of you who missed the beginning, compared to a stock DJI antenna, it was like an 8 or 9 dB gain, which is a huge gain over the stock antenna in terms of gain. Over 2 times the range you could expect if you're pointing in the direction that it can fly. Thanks for the question, William. If anyone else has any other questions, put them in chat. We'll try to answer them here while we still have Hugo and his wide knowledge of FPV antennas. Always appreciate you, Hugo, and all of your expertise in this area. How long have you been in the industry of antenna design and making?
Well, it's close to 10 years now.
Wow. Yeah. How did you get started in even designing antennas?
I started, as a hobbyist, like much people in this hobby, tinkering. Back in the days, there was not as much equipment available to the hobbyists, so we needed to tweak more, to sometimes make our own controller, or make a modify camera, modify video transmitter, and then there was not that much antenna available, so people were searching online for ham antenna, ham design, and making tutorial, and so I get into it. And since I have an IT background, I use computer simulation a lot to design the antenna. So I started like this, designing my own antenna, but in simulation. Then trying, building some. So I made thousands of simulation, learning things on the way, and the rest is all self-study. So I've learned online on an antenna. I made my own experiment. So using scientific method to ask a question and answer that question with an experiment. And I started make antenna for friend, make antenna for chat group, and then it went into a business without planning to do so. So yeah. And today the business is is doing pretty good, and it's pretty great. I could buy much better tool. I could buy a real industrial network analyzer. I could buy a new a aerospace grade simulation tool to make simulation of things that I could only dream of.
Yeah, I saw you post the other day.
Ago.
You got a new machine, a new tool in. Is that right?
Yeah, a new analyzer that goes to 28 gigahertz.
For those you don't know, I mean the price on those it's not at hobbyist level. You're going to only do
No,
it if you're really making these professionally.
no, it's super expensive.
Yeah.
But
Well,
thanks
I'm glad you can do them. Yeah.
yeah, because people, I had success with my antenna, and the resource that make it available, I can put it back into more research and make more product and more refined product.
Yeah, I think that's an important point. I mean,
Yes.
there's a lot of antennas on the market. You'll see a lot of cheap ones out there too, coming from China, or clones and copies. But I think one thing that always sets antennas apart, especially Lumenier, with your help, Hugo, and the design of those. I mean, the R&D, the testing, and the fine tuning that goes into it, with the help from some of those machines that you utilize, and then the knowledge that you've gained over all the years of how to use those machines in such an effective way, and the simulation tools and stuff like that. You're not just guessing and soldering wire together. It's really doing it through math and through trial and error, and then through really proving it out through simulation, which I think is really neat. And then on the production side, I mean, we have very rigid QC steps. Every antenna gets tested after assembly to make sure every connection's good and that it's passing QC. So, I mean, the Axie antenna line, we've had very few issues over the years of any kind of bad antenna go out the door. So I think that's very much up, or because of you and your design and how solid that design has been, to allow it to be manufacturable too in a repeatable way. Because making 5 or 10 of them is one thing, but when you're making thousands and tens of thousands of antennas, you have to be able to do it, repeat it, and make a solid antenna every time. That's not always the easiest thing to do. So I think that's really cool. You even told me about some new, antenna and updates designs you're working on, and I won't talk about the product, but going into that process, you're saying you're like able to simulate even at the level of during production, they can fine tune maybe even the design. Yeah. So as it's being made, you can make a little tweak that just gets that, effective, I guess, the bandwidth right where you want it, or the center channel, to tune it perfectly for our use case. Yes. Where other antennas, they just don't go to that length of fine tuning and making sure it's, perfectly matched.
On the process of making mass manufacturing of antenna, you just try to have some tolerance and then make a batch, and you just hope they fall into those tolerance. But as we make smaller and smaller antenna, just like our antenna are very small, the bandwidth, the amount of frequency can accept becomes very narrow, and then your tolerance are very, very tight. So I developed a technique to have an antenna that is mass produced but tuned on an individual basis. So each antenna is tested as right after it's being produced, and then tweaked on the assembly line to go out automatically at a peak performance. Awesome. So so each antenna will be maybe somewhat different, but the difference is very small. You can't really see it with your eyes. Maybe with a caliper you take measurement, but you could see that among antenna they are all a bit different. But it's not because the tolerance is not great. It's just that it compensates automatically as the antenna is being made and tested on the production line.
Mm-hmm. Looks like we've had a few more people join the chat with some questions. Christopher's asking, can you use this as a replacement for the Crossfire or tracer antenna? Christopher, the answer is no and yes. I mean, Crossfire works on a different frequency, not on 2458. It's on, I guess, 915 or 800 something. I'm forgetting off the top of my head. But this would work for the tracer antenna, since tracer works on 2.4 gigahertz. So yes, it is a replacement antenna for the tracer transmitter. And you could use this as a higher gain directional antenna. So that would work. Johnny Snipe says, hi, Hugo. He best antennas out there. So he gives you a shout out. Little love to Hugo for your antenna design. Thank you, Johnny, for joining us. For those of you who maybe don't know who Hugo is either, he is the original designer of the AXI antenna, the first, like I would call micro circular polarized antenna or mini circular polarized antenna. Back in the day, we did have circular polarized antennas, but they were all kind of this mushroom, larger shape, which was great at the time. But then the natural desire was, how can we go smaller, smaller, smaller? Hugo was able to design a network that allowed us to shrink that down without sacrificing the performance that we wanted out of that antenna. So if you look at the AXI antenna, that was, when did we release that? 4 or 5
years. Yeah, almost 5. Yeah.
Wow, can't believe it's been that long. But that was such a big game changer in the market of being able to fly, put that small antenna on your drone or your goggles, and it's allowed for weight savings, smaller antenna that you didn't have to worry about it hitting things so much. So that was so cool to have that transformation within the hobby of that antenna style. And where we're at today, we have micro AXI, we have AXI 2, where we've updated the original AXI design. We have AXI HD, which is a patch antenna. We have other patch antennas. We have this new Duality. We have the Duality Omni that got released earlier this year for DJI V2 goggles. It's a dual band, the first dual band circular polarized Omni antenna available. It's, I think, still probably the only one. I haven't seen any other dual band Omni antennas.
Me neither.
And then
it's not in the FPV market.
Yeah, and now the Dual-MOX, which is a dual band 5.8 and 2.4 antenna for the DJI system as well, but also for other 2.4 or 5.8 systems if you want to use that. So it can work on either frequency, or if you have the DJI system where it's going to use both and maybe switch back and forth, this antenna can do that. So Hugo, maybe explain for those who don't know how it works. How does an antenna do 2 frequencies? Like, to me, it kind of sounds like some kind of magic, but how does it know where to go? If it's doing 2.4 transmission or reception versus 5.8, how does it know where to listen? Or like, how is it different shapes inside that make that happen?
Yeah, there's a shape for 2.4 and there's a shape for 5.8. And when 5.8 is injected in the antenna, the shape is such that it blocks at the 2.4. It does not go inside the 2.4, but is emitted only by the 5.8 section. So the trick is to have both that are they don't affect each other's. That's the hard part. So you want to have some good properties at 5.8, but not to make a compromise on 2.4 while you do this. So I have to make 2 elements inside the antenna, but take care that the 2 elements don't walk on each other's, so to speak.
That makes sense. I'm sure that's the tricky part, because it sounds straightforward to say, oh, we'll just make a 2.4 and a 5.8 antenna and put them together, right?
Wire them together, it's not that simple.
But they would have a very bad experience if you just were to do that at home and stick two antennas together, right? Yeah.
So I use a high performance simulation tool, like I said, and I get an idea, let's try this, and either works or it doesn't, or maybe. So when I get the design in the computer, which is close to what I want, I make a prototype, and then I check if the simulation is right, and it usually do, and with a small tweak to be needed, and then I tweak the simulation, the design inside the computer to match what I observed in the lab, and then continue to refine the design, and then the antenna is ready after maybe 2 or 3 prototype run.
Great. Yeah. Ramil Robertson asks, what's the suggested position of the antennas relative to the quad? So Ramil, if you're using it on the goggle as like a receiving antenna, you would want to point the antenna towards where you're flying, or towards the quadcopter. Mm-hmm. So this would be pointing that way towards where you're flying. Same with this. So if you had all 4, you'd want to point them all towards a similar direction to get the best range and coverage. Now, if you want to fly a wider path, maybe more left to right of you, you could simply bend them out a little bit, and you'd still have some crossover since these are wide field of view. So these are about 120 degrees. So even though they're not all pointing in the same direction, you would have some coverage everywhere. Is that right, Hugo?
Yes,
In this case?
absolutely.
Yeah. So you could point them this way, that way, and as long as they're not like 180 degrees reversed, you would have some crossover and still have full coverage everywhere you're flying. But if you know you're flying in a certain direction, you want to maximize the range of their signal or penetration through objects, you'd want to point them in that direction to get the maximum gain out in front of the antenna. I hope that answers your question there.
And Santiago asked to tap our bottom ports, but just look at Andy's goggle. See the bottom left and top right ports are receiver only. So they are the most important for video. So they are the one to prioritize with a directional antenna. The difference, if you were to put the antenna onto the two other ports, it's not huge, but there's a difference.
Gotcha. Yeah. So if you want the max performance, get all four. If you want to do two and mix and match like an omnidirectional, like a duality stubby, then do it something like this and put the stubbies on the other locations.
This is for the V2 goggle. Okay, on the V1, the 100% receiver port is the lower left.
Okay, so it would be this one on the V1. You're saying is 100% receive is the most important.
Yes. Yeah. Okay. It's not a huge difference, but it's the port that does the most bandwidth.
So say you're flying just a normal drone with a DJI system, not the DJI FPV drone that's dual band, but a 5.8 fixed.
Mm-hmm.
Could you still use these antennas on a 5.8 system if you wanted to increase your range over the stock antennas?
Yes, you could still use them.
Yeah. Majid asks if these are right or left hand. These are actually linear antennas, so they're not polarized left or right. It's a linear antenna, so there is no polarization like you would be used to on a circular polarized antenna.
You will not have, as much range because of this as, using circular polarized antenna. Unless maybe on your build, your FPV build, you use linear antenna too. So in that case, maybe you could, more range.
That makes sense. For those of you joining us too, we do have these for sale right now. The new Lumenier Duality Dual-MOX Antenna. It's on GetFPV. It is enabled and for sale right now. We have them for sale in two versions. Set of four here you can see in front of me here. You can get all four for $54.99, or we sell them also in a single version if you want to mix and match or only buy one or two. You can do that at $15. So both of these are on getfpv.com right now. You can find them on the homepage, or you just search Duality or Dual-MOX Antenna in the search bar up there. You'll find them too. They're in stock and shipping right away. And we're really excited to be able to finally announce these to everyone, and hope you guys get a chance to try them, improve your range, get to explore a little bit more. Even if you're not going long range or that's not your goal, they can help you in flying situations. Is that right, Hugo? So say you're flying behind objects, a higher gain would improve your penetration. Is that right too?
Yes. So, sometimes people ask, I don't want long range, I want penetration, but it's the same. If you need to go through 10 miles of air or 10 meters of brick, that's a bit of the same.
Stephen asked a good question. He's asking, are these an upgrade to the Duality HD stubbies, or about the same? Maybe I'll try to answer it and let you answer it too, Hugo. I think it's really different. The Duality stubby is a circular polarized antenna. These would have a higher gain, so you're going to get, and they are directional antenna as well as being linear. So they're really kind of different use cases. I guess, Hugo, how would you explain, why would you use one over the other? What would be the situation?
For someone that use both the DJI FPV drone and the R unit and Vista, I will stay with Duality. But for someone who mostly use the FPV drone, or want to do a long range attempt with the FPV drone, then choose the Moxon, the Duality Moxon for that, definitely.
Okay. Interesting. Interesting. Is there any use cases on a transmitter side of like actually on the drone that would make sense for an antenna like this? I guess it'd have to be very specialized, or maybe if you had something on the ground or fixed that's always going to be in one position, you could get creative with something like this as a high gain transmission antenna.
Yes, you could. You
Can't think of something that exists today, but maybe
yeah.
maybe DJI will come out with a dual band standalone air unit or something that we can get creative.
If when they do, then I have design ready for this. I thought at the beginning, before they released the drone, that they were going to release a dual band air unit as well, but it didn't happen. So, but crossing finger.
Yeah, we can hope. We'll see. Nobody can quite understand what they're planning for the FPV crowd, but maybe that'll be something they think will be useful in the future. Who knows? Thank you for everyone who's joined us today and asked some questions along the way. I'm joined here with Hugo from TrueRC. We're going over the Lumenier Duality Dual-MOX antennas that were just released today. For those of you watching this video in the future, these are on the store right now for sale, and they'll be for sale in the future too. This is the Dual-MOX antenna, brand new from GetFPV, Lumenier, and with the help of TrueRC and Hugo with the design and manufactured by Lumenier. This is the dual band antenna, brand new, fits on the DJI goggles, RPSMA, so you don't have to do any kind of connectors to adapt them to the goggle. They screw right on. Easy to take on and off, so probably not something you leave on your goggle when you're traveling just because they stick out a bit, but to take off, it's very simple. I'm just going to unscrew it, and you're like 2 seconds later, you're done. Same thing, putting them back on, very easy. So it's an easy antenna to put on and off the system, and that makes it easy to travel with too, I think. Yep. Well, I think we'll wrap up there. Thanks again, Hugo, for joining us, and I really appreciate it. Hope we can talk again soon and show some people maybe some new antennas coming out here in the near future.
Oh, there will always be. Yeah, I got plenty of surprise.
I believe it. We appreciate you and all the work that you've done for this industry and the hobby. And I know I've used personally many of your antennas over the years, and they help us get further and farther than we ever thought we could with FPV. So that's really cool. I remember the early days, like you explained, when the choices were very limited and the performance was very poor, I would say, overall in terms of our antennas, what we could use. So it's certainly been a big part of the evolution of FPV and our wireless signals, allowing us to fly further and in places we couldn't before. Very cool. Hey, thanks, William. William says he's got him in his cart. He's working to check out, so that's awesome. Appreciate it, William. All right, Hugo, I'll let you go. I'll wrap it up here then. Thanks again. Thanks, everyone who joined us here, and we'll see you again soon. Before I go, I just want to show you guys, this is the new GetFPV studios behind me. We have a whole wall of history, I call it, of drones, different kind of electronics over the years that we've been a part of at GetFPV, or we've designed under Lumenier or other brands as well. I hope to, in a future episode, show you guys a little behind the scenes of what's behind me, because there's a story behind every drone behind me, which is an interesting story, at least to me. I think that could be a cool way to share with you guys what we've worked on over the years, give you a little bit behind the scenes. Thank you again for everyone who joined us. Thanks for tuning in. Lumenier Duality Dual-MOX antennas, again, live on the site for sale right now on getfpv.com. Check them out. Hope you get a chance to try them. Stay tuned. If you haven't yet, subscribe to us on YouTube or join our Facebook group. Click the notify button, and that way any future videos we come out with live, you'll be notified right away. You can join in the conversation. Appreciate that. Bye-bye, everyone. Have a great afternoon. See you later.